The Solar System. Chapter 1. The Sun. The Sun is the largest and most massive object in our solar system, accounting for over 99% of its total mass. It's also the closest star to Earth, located about 93 million miles away. The Sun is a massive ball of gas, primarily composed of hydrogen and helium, which is held together by its own gravity. The Sun's diameter is about 1.4 million kilometers, which is about 109 times larger than the Earth. However, its mass is only about 333,000 times greater than Earth's, which means that the Sun has a much lower density than the Earth. If you could somehow place the Sun on a giant scale, it would weigh about 330,000 times more than the Earth. The Sun's surface is called the photosphere, which is the visible layer that emits the sunlight that we see. The photosphere has a temperature of about 5,500 degrees Celsius, which is much cooler than the Sun's core, where temperatures can reach over 15 million degrees Celsius. The core is the region where nuclear fusion takes place, which is the process that generates the Sun's energy. The Sun's energy is released in the form of electromagnetic radiation, which includes visible light, ultraviolet light, and X-rays. This energy travels through space at the speed of light and takes about 8 minutes and 20 seconds to reach the Earth. The Sun's magnetic field is also an important aspect of its behavior. The magnetic field is generated by the movement of charged particles within the Sun's interior and can cause a wide range of phenomena, such as solar flares and coronal mass ejections. These events can release vast amounts of energy and can have significant effects on the Earth's atmosphere and technological infrastructure. The Sun also rotates on its axis, completing one rotation every 25.4 days at its equator and taking longer at higher latitude. The Sun's rotation can cause sunspots, which are dark, cooler regions on the surface that are caused by the Sun's magnetic field. The Sun's behavior is constantly monitored by astronomers and space agencies around the world. There are many solar observatories that study the Sun's activity and its effects on the Earth's environment. Solar flares and coronal mass ejections can cause disruptions to satellite communications, power grids, and other technological systems, so it's important to monitor the Sun's activity to minimize these effects. The Sun's behavior can also have an impact on the Earth's climate. The Sun goes through cycles of increased and decreased activity, which can cause variations in the amount of energy it releases. These cycles can last for several decades and can have a noticeable impact on the Earth's climate. For example, during the Maunder minimum, a period of low solar activity in the 17th century, Europe experienced a little ice age, with colder temperatures and more severe winters. In conclusion, the Sun is the center of our solar system and is responsible for providing light and heat to all the planets. It's a massive ball of gas that undergoes nuclear fusion to generate its energy. The Sun's magnetic field and rotation can cause a range of phenomena, such as solar flares and sunspots. Monitoring the Sun's activity is important for understanding its effects on the Earth's environment and technological infrastructure. The Sun's behavior also has an impact on the Earth's climate, which can vary depending on the Sun's activity cycles. Chapter 2. The Inner Planets. The inner planets, also known as the terrestrial planets, the 4 planets closest to the Sun: Mercury, Venus, Earth, and Mars. These planets are made mostly of rock and metal and have a solid surface, unlike the gas giants in the outer solar system. In this chapter, we'll explore each of these planets in more detail. Mercury is the smallest planet in the solar system and is located closest to the Sun. It's about 38% the size of Earth and has a rocky, cratered surface. Because of its proximity to the Sun, Mercury is very hot, with temperatures reaching up to 430 degrees Celsius during the day and dropping to -180 degrees Celsius at night. Mercury has no atmosphere to speak of, so it has no weather or wind. It also has no moons or rings. Venus is the second planet from the Sun and is often called Earth's sister planet, because of its similar size and composition. However, Venus has a very different climate and environment from Earth. Venus has a thick atmosphere composed mostly of carbon dioxide, which creates a runaway greenhouse effect that traps heat and causes temperatures to soar to over 460 degrees Celsius. The surface of Venus is hot enough to melt lead and is covered in volcanic plains and mountains. Venus also rotates very slowly, taking about 243 Earth days to complete one rotation. It has no moons or rings. Earth is the 3rd planet from the Sun and is the only planet in the solar system known to support life. Earth has a unique environment with a mix of gases in its atmosphere that allow for the presence of liquid water, which is essential for life as we know it. Earth has a solid surface with mountains, oceans, and deserts, and is orbited by a single moon. Earth's atmosphere protects it from harmful radiation and also creates weather patterns that can be beautiful and destructive. Earth has a moderate climate compared to the other inner planets, with an average temperature of about 15 degrees Celsius. Mars is the 4th planet from the Sun and is often called the red planet because of its reddish appearance in the sky. Mars has a thin atmosphere made mostly of carbon dioxide, which creates a very cold and dry environment. The surface of Mars is rocky and contains canyons, volcanoes, and polar ice caps. Mars also has the largest volcano in the solar system, Olympus Mons, and the deepest canyon, Valles Marineris. Mars has 2 small moons, Phobos and Deimos, which are irregularly shaped and are likely captured asteroids. The inner planets have several similarities, such as their rocky composition and lack of rings, but also have significant differences, such as their atmospheres, temperatures, and surface features. Studying the inner planets can give us insight into the processes that formed and shaped our solar system and can also help us understand the potential for life beyond Earth. Chapter 3. The Outer Planets. The outer planets, also known as the gas giants, are the 4 largest planets in the solar system: Jupiter, Saturn, Uranus, and Neptune. These planets are much larger than the inner planets and are mostly made of gas and ice, with no solid surface. In this chapter, we'll explore each of these planets in more detail. Jupiter is the largest planet in the solar system and is over twice as massive as all the other planets combined. Jupiter is a gas giant and is mostly composed of hydrogen and helium, with no solid surface. Jupiter's atmosphere is composed of bands of clouds that rotate around the planet, creating the planet's distinctive stripes. Jupiter also has a large red spot, which is a massive storm that has been raging for over 300 years. Jupiter has at least 79 moons, including the four largest, Io, Europa, Ganymede, and Callisto. Saturn is the second largest planet in the solar system and is also a gas giant. Like Jupiter, Saturn is mostly composed of hydrogen and helium, with no solid surface. Saturn is known for its impressive ring system, which is made up of icy particles ranging in size from small grains to large boulders. The rings are believed to be the remains of a moon that was destroyed by Saturn's gravity. Saturn has at least 82 moons, including Titan, which is the only moon in the solar system with a thick atmosphere. Uranus is the seventh planet from the Sun and is an ice giant. Uranus is composed mostly of water, ammonia, and methane, which give the planet its distinctive blue-green color. Uranus is unique among the planets in the solar system because it rotates on its side, with its axis tilted almost 98 degrees relative to the plane of its orbit. This means that the planet's poles are located where other planets have their equators. Uranus has at least 27 moons, including Miranda, which has the most varied terrain of any moon in the solar system. Chapter 4: Dwarf Planets and Small Bodies. In addition to the 8 planets, there are many other objects in the solar system, including dwarf planets and small bodies. These objects are diverse in size and composition and play an important role in the solar system's history and current dynamics. Dwarf planets are objects that are too small to be considered full-fledged planets but are large enough to have their own gravity and be roughly spherical in shape. The most famous dwarf planet is Pluto, which was once considered the 9th planet in the solar system but was reclassified as a dwarf planet in 2006. Pluto is located in the Kuiper Belt, a region of the solar system beyond Neptune, and is composed of rock and ice. Pluto has at least 5 moons, including Charon, which is the largest and is so large compared to Pluto that some scientists consider it a binary system rather than a single planet and moon. Other known dwarf planets include Ceres, which is located in the asteroid belt between Mars and Jupiter, and is the largest object in that region, as well as Haumea and Makemake, which are located in the Kuiper Belt. In addition to dwarf planets, there are also many small bodies in the solar system, including asteroids and comets. Asteroids are rocky objects that range in size from small rocks to large bodies like Ceres. Most asteroids are located in the asteroid belt between Mars and Jupiter, but some have been found in other regions of the solar system as well. Comets, on the other hand, are icy objects that originate in the outer regions of the solar system and have highly elliptical orbits that bring them close to the Sun. As they approach the Sun, the heat causes the ice to evaporate and release gas and dust, creating a coma, a hazy atmosphere around the comet, and a tail that can be seen from Earth. Studying dwarf planets and small bodies can help us understand the early solar system and the processes that led to the formation of the planets. These objects also have potential as resources for future space exploration, as asteroids and comets contain valuable minerals and water that could be extracted and used in space missions. In conclusion, while the 8 planets are the most well-known objects in the solar system, there are many other fascinating objects to study, from dwarf planets like Pluto to small bodies like asteroids and comets. Understanding the diversity of objects in the solar system can give us a better understanding of the solar system's history and dynamics, and also provide opportunities for future exploration and discovery. Chapter 5: The Kuiper Belt and Oort Cloud. The Kuiper Belt is a region of the solar system beyond Neptune that contains a large number of small icy bodies, including dwarf planets such as Pluto. It is named after Gerard Kuiper, the astronomer who predicted its existence in 1951. The Kuiper Belt is estimated to contain billions of objects that are larger than 1 kilometer in diameter, as well as many smaller ones. One of the most famous objects in the Kuiper Belt is Pluto, which was considered a planet until 2006, when it was reclassified as a dwarf planet. Pluto is the largest known object in the Kuiper Belt, with a diameter of about 2,377 kilometers. It has a highly eccentric orbit that takes it from 29.7 astronomical units, AU, from the Sun at its closest approach to $49.30 at its farthest. The Kuiper Belt is believed to be the source of many short-period comets, which have orbits that take them around the Sun in less than 200 years. These comets are thought to have formed in the Kuiper Belt and were then kicked out into the inner solar system by the gravity of the giant planets. Beyond the Kuiper Belt lies the Oort Cloud, a spherical shell of icy bodies that surrounds the solar system at a distance of up to 100,000 Australian dollars from the Sun. The Oort Cloud is believed to be the source of long-period comets, which have orbits that take them around the Sun in more than 200 years. The Oort Cloud is named after Jan Oort, the astronomer who first proposed its existence in 1950. The Oort Cloud is much less well understood than the Kuiper Belt because its objects are too distant and too faint to be observed directly. However, its existence is inferred from the orbits of long-period comets and computer models of the early solar system. The Kuiper Belt and the Oort Cloud are important for understanding the early history of the solar system. They contain remnants of the primordial material that formed the planets and offer clues about the processes that led to the formation of the solar system. Furthermore, they provide targets for exploration by spacecraft, such as NASA's New Horizons mission, which flew by Pluto in 2015 and is now heading towards another object in the Kuiper Belt. Chapter 6: Exploration of the Solar System. Since the dawn of the space age in the late 1950s, humans have sent a variety of spacecraft to explore the solar system. These missions have provided us with a wealth of information about the planets, moons, asteroids, and comets that make up our cosmic neighborhood. One of the earliest and most famous missions was NASA's Apollo program, which sent humans to the Moon between 1969 and 1972. The Apollo missions provided us with the first up-close look at another celestial body and gave us insights into the geology and history of the Moon. Since then, a variety of other missions have been sent to explore the planets, moons, and other bodies in the solar system. For example, NASA's Viking missions in the 1970s explored Mars, while the Voyager 1 and 2 spacecraft, launched in 1977, flew by Jupiter, Saturn, Uranus, and Neptune and provided us with detailed information about these giant planets and their moons. More recently, NASA's Cassini mission, which orbited Saturn from 2004 to 2017, provided us with detailed information about Saturn, its rings, and its many moons, including the intriguing moon Enceladus, which is believed to have a subsurface ocean that could potentially support life. Other notable missions include NASA's Mars rovers, such as Spirit, Opportunity, and Curiosity, which have explored the surface of Mars and provided us with insights into the planet's geology and history. The current and future plans for exploring the solar system are even more ambitious. For example, NASA's Perseverance rover, which landed on Mars in February 2021, is searching for signs of past life on the planet and collecting samples that will be returned to Earth by a future mission. In addition, NASA's upcoming James Webb Space Telescope, set to launch in 2021, will study the formation of galaxies, stars, and planets, and search for signs of life beyond our solar system. Exploring the solar system is important not only for expanding our knowledge of the universe but also for inspiring new technologies and pushing the boundaries of what is possible. The continued exploration of the solar system promises to reveal even more surprises and mysteries about our place in the cosmos.